Okay, fourth graders, today is Thursday, January 30th, and we are doing Eureka Math Module 5, lessons 20 and 21. And today we're going to combine these two lessons because they're both about using pictures to help us add fractions. We're going to use tape diagrams to help us and number lines because those are both different kinds of pictures that we can use to draw. Okay? Let's first talk about the problem of the day. It said, Krista drank 3/16 of the water in her water bottle in the morning. Then 5/16 in the afternoon, she drank 5/16 in the afternoon, and then 3/16 in the evening. What fraction of the bottle of water was left at the end of the day? The first thing we need to figure out is what is this question asking us to find? What is the question asking us to find, Arnav?
What fraction of the bottle of water was left at the end of the day?
Okay, we want to basically find out how much water was left at the end of the day. Okay. What important information do we need in order to figure that out? Swarnima? First she drank 3/16, then she drank 5/16, and then she drank another. Very good. So if we draw a picture, if this is all of her water, we have to split all of her water into what size units? Avani? 16s, because everything is in 16ths. So I'm going to do it into fourths, and then each fourth will be split into 4 more, so that I have 16. Okay, good. Now I can show that in the morning, she first drank 3/16. And not only will I shade it in, but I'm going to label that she drank 3/16. Then she drank another 5/16. So 1, 2, 3, 4, 5. I'll shade those in. I'm going to label that that's 5/16. Then in the evening, she drank another 3/16. So I will label and shade in 3 more 16ths. Okay. Now, the question's asking us how much water was left. So this is how much was left, right? So how many 16ths are left? Everyone?
5/16.
Good, 5/16. But 5/16 of what? Of a gallon? Of the rain? Let's look at the question. It says, of the bottle. So I know that my label needs to be of the bottle. Very nice. So the directions tell us in this one to draw a tape diagram to represent each addend. An addend is one part of the addition sentence. So this is an addend and this is an addend. How many addends are there? 2. So if it says to draw a tape diagram to represent each addend, how many tape diagrams should we draw? 2, because we need one tape diagram to represent the first addend, and then we need to take a second tape diagram to represent the second addend. So let's go ahead and do that right now. The first addend is 1/4. So I'm going to have 2 pieces of tape, one for each one, right? And I'm going to show 1/4. I'm going to shade in one of the fourths. Okay, very good. Now, for the second addend, we have 1/8. So I have to make eighths, and I have to shade in one of the eighths. Then the directions tell me to decompose one of the tape diagrams to make like units. Decompose means to cut it into smaller pieces, right? To break it apart into smaller pieces. So should I decompose the first tape diagram or the second tape diagram? Everyone?
First.
Good. Because I can decompose it, instead of fourths, I can have eighths as well. And then I can see that 1/4, therefore, is equal to 2/8. And 1/8 is still 1/8, right? Now I have like units. What are my like units? What are my like units? I let eighths. So then it says to write a complete number sentence. Well, 1/4 plus 1/8, I know now that 1/4 is the same as 2/8, right? So instead of 1/4, I can write 2/8 plus 1/8. And how many eighths do I have altogether? 3/8. Don't forget that a complete number sentence has the equal sign and the answer at the end. Okay? Then it says use a number bond to write the sum as a mixed number if possible. Is it possible to write this sum as a mixed number? No. So we are done with this example. Great. Let's try this one. Same directions. It says draw a tape diagram to represent each addend. So I have 3/4. I'm going to first show 3/4. And then I have 1/2. I'm going to show 1/2. Now it says to decompose one of the tape diagrams in order to make like units. Should we still decompose the first tape diagram? No, this time we should decompose the second one because I can make halves into fourths. And when I do that, I show that 1/2 is equal to 2/4. Do you guys agree? So now I can rewrite my number sentence using like units. 3/4 is still 3/4 because the units are still fourths. But instead of 1/2, I can write 2/4. And now I have like units so I can add. If I have 3/4 and I want to add 2 more fourths to it, how many fourths do I have altogether? Haruto?
5/4.
5/4. Now in this case, is it possible to write that using a mixed number?
Yeah.
Yes. So let's show it using a number bond. I can show that 5/4 is the same as, how many fourths are in one whole? Everyone? 4/4 plus 1/4. So this is equal to 1 whole and 1/4. That's the answer written as a mixed number. So make sure we are doing every part because there's a lot of directions, a lot of steps in these directions. It said to draw tape diagrams to represent each add-in. We did that. Then it said to decompose one of the tape diagrams. We did that in order to make like units. Then write a complete number sentence, right here, and then use a number bond to rewrite the answer as a mixed number. Okay, several steps in these problems. This time, it says to use a number line to model the addition. Then we're going to, of course, write a complete number sentence and use a number bond if possible. So we have a number line. Let's go ahead and draw from 0, maybe to 1, and maybe to 2, because that's the biggest our answer could be, right? It's going to be somewhere between 0 and 2. Now, if I have 1/2, that means I have to divide the distance between 0 and 1 into halves, right? 1 is the same as 2 halves, and then that would be 3 halves, and this would be 4 halves. Do you guys agree? Right? So I have 1/2, and then I have to add a fourth. So let's go ahead and add fourths too. So this would be 1/4. 1/2 is the same as 2/4. It's the same as 3/4. Okay? So if I start with 1/2, I'm going to go from 0 to 1/2. This is adding 1/2. But then I have to add one more fourth, and I'm going to move one more fourth and show it like that. So then when I'm done, my answer is right here, right? So what is my answer? Everyone? Everyone? What is my answer? 3/4. So to complete the number sentence, I can write 1/2 plus 1/4 equals 3/4. And I know that because I know that 1/2 was the same as 2/4. Because when I decomposed the number line, I could see that 1/2 equals 2/4. Okay? Can we write this answer, write the sum as a mixed number? No, so we are done with this one. Once again, this question is asking us to use a number line. Okay, so we have 7/10 plus 3/5. So let's go from 0 to 1 to 2 again. And this time I could first decompose it into tenths, right? 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we can say this is 1/10, 2/10, etc., right? What do we know about 2/10? 2/10 is the same as 1/5. Okay, so if my first thing that I need to do is go from 0 to 7/10, I can count 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to write this is plus 7/10. Now I have to add 3/5. Well, I know that 3/5 is equal to how many tenths? 3/5 is equal to how many tenths? Because since my number line is in tenths. Kashyap, 3/5 is the same as how many tenths?
6/10.
6/10. So if I want to add 3/5, it would be like this. 1, 2, 3. Wouldn't it? Same thing as adding 6/10. Okay, so I'm going to write plus 3/5. Okay, so I'm done. So my answer is right here. Where is this on the number line? Where is this spot? Is it bigger or smaller than 1? Bigger, right? How much bigger? It's 1 and 1/10, 2/10, 3/10. So the answer is 1 and 3/10. So let's complete the number sentence. This would be, if I wanted to make like units, I could say that this is 6/10 plus 7/10. Do you guys agree? What's 6 plus 7? 13/10. And then using a number bond, would that equal 1 3/10? Yes, it would. Very good.